Hi, I'm Dr. Sri Banerjee, and in this video, I will be going briefly over confidence intervals. Confidence intervals, at first glance, can be quite confusing, but if we understand this as a kind of way to characterize uncertainty, then I think this becomes easier. Uncertainty is something that is introduced not only when you are taking a simple measurement. Say you're trying to take the measurement of the width of a window because you're trying to replace it. So when you're taking measurements, sometimes the measurements are off. I had to actually take multiple measurements before realizing the right dimensions. So simply understanding that there is uncertainty. And so similarly, when you're taking a sample, by now you understand that the sample is only a subset of the population, so there's some error that there always is introduced. One of the most common percentages of confidence intervals is 95% confidence interval. Now, if you were to accept a bit more, and so if you wanted a little bit more confidence, then 99% is something that is typically seen. So, in the field of statistics, typically statisticians use confidence intervals in a sample variable when describing where one sample is in relation to another sample. So what does this mean? So say you were to take multiple samples. So about 340 million individuals reside in the United States. So say you were to take a subset of that population, and then again, now take another subset. So how are these samples different? And so the resulting data sets are all different, and some intervals actually will include the true population parameter. And this is what you'll see. So a confidence interval, another way to look at it is that it's a set of ranges or a range of values. And these range of values are what binds or is bounded above and below the parameter measure that you're after. So when I say parameter measure, one such parameter measure can be mean. And so the confidence level refers to the percentage or probability or certainty that the confidence interval would contain the true population parameter when you draw a random sample many times. You can say that we are 99% certain, or at a 99% confidence level, most of these samples contain the true population parameter. Um, what's a misconception? Now, one misconception is that it represents the percentage of data from a given sample that falls between one value or another. So it is not, for instance, a 95% confidence interval does not represent 95% of all of the data falling within this level. So I hope you've understood a basic running sort of definition of what a confidence interval is. Try to think about this a little and make sense out of this. Try to look at different sources and try to understand. And I'm going to go through a demonstration now to show what exactly it is you can do in SAS to run a confidence interval. Okay, so in this portion of this video, I'll be going over a demonstration of how to provide and how to have an output of confidence intervals and what to make sense of when you get this output. So first of all, let's go through the menu items. Again, orient yourself, get used to orienting yourself in this sort of interface of SAS Studio. This is actually, again, the cloud-based interface being used here, and There's several sort of data sets that are included within this interface. And then if you go into tasks and utilities, this is where you'll find a lot of useful sort of functionalities that SAS actually has. And again, the shift between menu-driven and syntax-driven. So going from syntax-driven and menu-driven options is something that is a skill that you'll gradually develop. But for starters, I think it's important to have a good grasp on menu-driven options. So let's look at what is available again here. And if we're characterizing the data, this is a really good place to start. And one data set that is good to characterize, especially when we're thinking about confidence intervals, is a continuous variable. You don't want to be having a confidence interval for categorical variables. These really don't make sense as much because in confidence intervals for continuous variables, means make for a good confidence interval. So there's a margin of error that you can kind of look for when you're thinking about the mean of a continuous variable. So what is the mean that we're looking for? Well, C-reactive protein is a good inflammatory biomarker to be looking for. It's continuous. It's in micrograms per deciliter. And so let's take a look at the gender differences between C-reactive protein. So we can look for the variable that represents gender within NHANES. So again, this is using National Health and Nutrition Examination Survey between the years of 2005 and 2010. So this takes a look at how some of these various variables look like. So let's make sure in options we have the proper selections. And so there's descriptive statistics, there's frequency tables, and then let's look at the information. So this will give some of the information that we were looking for, but this is a good example of sometimes you might have to look through multiple menu items to try to get to the proper sort of output that you're looking for. Over here, you can see we have some important information, not exactly what we were looking for, but we do have the mean, as you can see, and then the standard deviation. Now you're looking for confidence intervals. We also see with a quick sort of frequency distribution of how many of each there was. So frequency distribution of C-reactive protein measurements in males versus females. So there was it was pretty evenly drawn. The measurements were evenly drawn for each gender. Let's also look for other ways that we can understand this data. So we can look at C-reactive protein now and take a look at the list data attributes. And then we can also look at list data. And under list data, then you can also look for various ways that you can have output. But the best way, which I'll show now, is looking at some of these data exploration and then summary statistics. The summary statistics will show you especially the confidence intervals. So you can see, I wanted to show you some of the selections of other options that you do have, but here is now the real way now that you can find confidence intervals. And so there's a C-reactive protein, and then there is the gender distribution of C-reactive protein right here. And then options, make sure again, remember I always look in options and look at the confidence. Now we're looking for the confidence limits for the mean. So here's the output. And so right here is the output And now you can see the lower confidence interval, the lower bound, and then the upper bound. So there's the lower bound and there's the upper bound. And that's for males. And then for females, there's the lower bound and there's the upper bound. So I hope this has helped. This has not only shown you the process of getting to the confidence interval, but the process of looking through some of the various menu items to see if what you are after, the measurement that you are after, is what's there. Now go back and take a look at these numbers and try to interpret based on the first part of this lecture. Try to interpret what the confidence interval is. Thank you for listening.